So I'm Caleb. This is entitled Insteon, Inste-off, Inste-open, maybe? We're going to get into it. Who am I? I'm a researcher, computer science background. I am really new at all the signals stuff, so it kind of intimidates me a little bit, but it's interesting, and I'm getting better. Kind of a tech hobbyist. I like fiddling with things sometimes. More of a soccer enthusiast, actually, but that's okay. So prior work, net admin and project manager. I'm currently doing network security, evaluating Insteon. So Ben is the other person supposed to be here. He had surgery recently to have his appendix removed, so that kind of stinks. PhD in computer science, wireless geek. A lot of Z-Wave stuff from him. DerbyCon, SmooCon, PUC, GTFO. You can go see all those things. Okay.
Stay in this general area, which
Okay.
you probably will anyway because it's right in front of your laptop.
Right.
If you want to use the clip-on mic, go ahead and take off your badge.
Sure, I'll do that.
Yeah. And put that in, the little clip on that onto your pocket. Let's see, yeah, they're right in there.
Perfect.
Do a little test, make sure.
Hello, hello.
Not on? This one's on. Is there on off?
There's a mute button. There we are.
There you go.
All right. I guess we'll get going here then. YouTube videos, all that stuff. It's good stuff. So real quick overview of the presentation. Lay out some goals for what I was looking to do. Review what Insteon is. Look at what's been done before, how I made some of it better. Quick demo and questions. The main goal is to validate and improve any previous work. I was just, what's out there, what's been done before, how's it working or doesn't work, whatever it is. Out of that came, I wanted to make it Wireshark capable and make sort of a network enumerator scanner type of tool. Even though I don't like goals, right? So, can't. Thank you, Yogi, for that one. What is Insteon? Insteon, home automation devices, brand, really. They have lots of stuff. Some of their documentation goes into really in depth in what they can do. Not all their products. And I don't think they really maxed out the product capabilities, but whatever. It sets up when you set up your network, it actually creates a mesh network, both RF and power line. You can connect to anywhere. Anybody have the app on their watch? I assume off phones, right? So you can 3G it back to your home, see if your garage door is open, see if your sprinklers are on, see whatever you want to see. It integrates with a lot of third parties, so the Amazon Echo, like this is on their website. Amazon Alexa, turn on the lights, and the lights will come on. It's pretty cool, right? So, woo. All right, next. So, in about 3 clicks on their website, you can find their public protocol information, right? And go through all that, 915, Manchester, whatever. Find their packet structure, what it looks like. See the standard and extended, whatever. So, really fast, you can find that stuff. Well, that seemed all good to me. I was like, wow, this seems pretty easy. I'm going to plug this into the SDR and start going. Had it been done before? Well, yes, actually. About the time I started this, Peter Shipley's talk was put on YouTube and everything. It was great. Fantastic. Okay, so there's a tool. So he presented this, right? Everybody remember this? Everybody seen this YouTube? It's a great one. He was like mad at Insteon. Insteon lied to him personally about his documentation. Bullshit, he said. Not 915. Not really Manchester. All the deviations wrong. It's great. Here's what he said. It's just tuned down just a little bit. Tokenized managed. It's not really just, 1-0 is not really a 1, 0-1 is not really 0, whatever. FSK is inverted, all this stuff, okay? He was angry. How do I do that? Yep. So the actual packet order is mixed around. Peter found this out. The tokenized Manchester comes from the bit at the bottom. They kind of, each of those X's, each of the bytes gets chopped up a little bit, and a 1-1 followed by some other stuff, and then somehow it comes to be the byte. So, interesting stuff, great stuff. So, after some pretty heavy frequency testing, we strapped up some stuff to a really expensive frequency tester. I'm sorry, Peter, it's 9:15. That's all right. I got to give credit to him. His parser, most of the stuff is fantastic, great stuff. But we were actually able to find his code. I didn't check this morning, but as of like last week, his code had 914.95. And so using the R sticks, which I'm using, we were able to tell that I was only getting like maybe 50% with the R sticks, and then fixing the frequency, we get up to about 80% packet reception. So that's awesome. So fixing the frequency, that was kind of the first main fix. Okay, so here we have a packet structure. Just kind of not really a correction, kind of an addendum to the packet structure. So Insteon advertised source, then destination, flags, etc., etc. Those are flags and source are switched, as it turns out, on most of the packets. I completely agree. I validated that. So there's another packet, another type of packet. Peter didn't address in his slides or his talk, but there's some devices you can set up rooms or scenes in your devices, so that this is actually set up how my setup is. The sensor not only tells the hub that it's open, but it also tells the light that to turn on, right? So I can turn on the light from the sensor. That's how you get Alexa to turn on all the kitchen lights, right? You tell these devices to work together. And that's done with a group broadcast command. And so the destination of the group address actually gets moved to the third set there. And so it's, again, kind of a flipping the bytes around. Cool. So kind of an addendum, not really a correction, but addendum, I'm going to say. So here we are. We've fixed frequency, corrected some packet structure details. So goal number 1 is done. How can I make it better? Well, Peter did, like I said, great stuff as far as reversing it. But it was all command line. And like I mentioned, I'm computer science. I like command line. It's good. But I want something that's kind of de facto, gold standard. I want this in Wireshark. And I'm going to start making a network enumerator. I want to know what. It's good that I know the device IDs, right? I can just see those in the listen packet, in the listener. But I want to know what are those devices? What are they? So has anybody made a program to output to Wireshark or included that in any way? You did it. Cool. Anybody else? No? Sweet. So there's kind of two methods of doing it. I guess you can make some C code and redo your make files and rebuild Wireshark altogether. Or you can modify the init Lua and make a new Lua file and incorporate the dissector that way. That's the route I decided to go. It seemed pretty easy. It's a little simple protocol. It's not a huge dissector file. So then you got to tell Wireshark that when you see this kind of packet, treat it like an Insteon packet. So here's what you got to do. Go to the edit preferences, use your DLT table, and when you see the little green box with your protocol, you know that it's going to work. Okay. So then it's just converting the data, this string of packets, or packet string, whatever, into PCAP data format. My code is on GitHub. I'm not going to show you code here, but it's on the GitHub. It works fantastically. So I can write data to a file or a named pipe, which is how I'm going to get it into Wireshark later. The code at the bottom is kind of what my code's based on, so I want to give credit there. Okay, so output Wireshark. Awesome. So it really want to know, okay, like I said, I can see these devices communicating when they communicate. They're kind of bursty. What are they? I have a lamp up here, but it could be anything. It could be someone's thermostat. They want to open the door, turn the thermostat down, right? So yeah, I need those device IDs, but I can I can definitely enumerate your devices. Okay. So to go about doing this, I needed some commands that would be helpful to do that, right? So not just on or off, but ping and ID. That sounds like a great start. What you think? So ping is just what you'd expect. The device responds. ID request kind of starts off like ping. It responds with the same command. But then it also sends this standard broadcast, set button, press response, whatever that means. Standard broadcast message. Okay, and we talked about the broadcast message has some information about the source, actually. So the broadcast message contains a 2-byte device type and a firmware version byte. This is from their documentation. So that sounds like a great way to go about this. Device type, firmware version type. Okay. So there it is. I found this as of 2007, circa 2007. So this still works. Like these devices do it right now. So I can see that this is device type 3, subtype 33, firmware version right there. Okay, that's cool. I don't know what device type 3 means. It's just a number to me. Well, not anymore. As of 2008, they had some categories of the devices. So I can know what my hub is. This guy right here. I can see what the light is. I can see what the thermostat, if I had that hooked up, see what the thermostat is. Climate control, good stuff. So that's what I do. I wait. I can't really inject anything onto this network until I have some IDs. Those are hard-coded onto each device. Spoof the ping and ID requests to really get the relationships, the controller-responder relationships, and start generating a map by tracking and labeling these devices. So that's, I have a couple more devices I didn't bring, but I have kind of done this for my network. So great. So here's copyright stuff, credits. Obviously, Peter Shipley was huge in getting this started. And then their documentation is fantastic. So I'm going to cut over to wireless demo real fast. This is totally going to work. So first thing, like I said, I have to create a named pipe, make FIFO, create named pipe. We're going to do that right now. Oh, it already exists. Hold on. We're going to do that real fast anyways. All right. Wireshark. Wireshark-I live capture. So here comes Wireshark. And I'm going to start this guy up. Okay. So this is the listener command. I have two yardsticks up here. So -I0 is for the first one. Let me do that. That's a good call. Thank you very much. Make it yeah. Is that better? Okay. -L for live and -P live capture. So here we go. So we're listening. So I'm going to create a scene. Here we are. We're listening. So I can see this is the map side of it over here. So I can see who the controllers are, who the responders are. I don't yet know what is what. That's the top part. I don't yet know what is what. We're going to start filling that in. So I'm going to minimize that. Over to the scanner, the different interface, 0, instead of 0, we're going to use a 1. Is that over there enough? So you can see that. All right. So like I said, we're going to spoof these commands between devices, and I'm going to start filling this in. Sent. All right. Here we are. There's your hub. And there's your light. I can see who exactly responds to who and who controls who. Everything makes sense? Pretty cool. So that's pretty much it. That's in about 13 minutes. That's what I did. Cool. Any questions? That's all I had. There's the codes up there. Any questions at all? Yeah.
So in terms of security here, it's basically non-existent, whether it's any wireless device from the light bulbs to the door locks to anything.
Correct. From what I can tell, they advertise encryption, but I don't have any devices that use it.
Yeah, it's all in the payload.
It's all in the payload and not in the devices itself, so not in the device IDs. Something I am going to start looking to is how fast can I spoof any device ID, or if there's a hidden ID on all the devices that they respond to. I don't know. So that's kind of the next way forward. But any other questions?
What about the other hubs and stuff? Are they vulnerable to the same thing, like Samsung Hub or?
So the documentation does have a subtype. There's a main device type and subtype. Like I said, the documentation is old, so this thing says a subtype 33. It's not listed on their 2008 documentation, so I didn't want to incorporate that into this tool. But those would each have, I assume, their own device subtype. But if they're a hub or a network bridge, is what they call them, then it would be that main type 3.
But it's not changing the security aspect of it.
It's not. You can still tell it's a hub. It changes between two networks somehow. Another question over here.
I saw the device listed things including controlling the keyboard and mouse for computers.
Yeah, I haven't. Some of those things I haven't actually seen products. Like they've made these categories, but I haven't seen any products for it. So things like car starters and stuff. I don't know. Maybe they had it back in the day, and they don't seem to have it anymore now.
Yeah, that's open ID really concerning.
Yeah, exactly. Right. Even your thermostat. Like if I did this and sat outside your house and watched you open your door and turn your thermostat down, well, now I can go turn your thermostat up and run your heat up or run your AC on for all day, right? So it's not very hard. I have not tested a lot of distance. Obviously, you could get a directional antenna and set up shop quite a ways away. 915, they advertise 100 meters for 915 megahertz. So I have not touched the power line directly. I think as long as it's going to jump from power line to RF, I'll get it anyways. So.
I was about to say, even if you only are power line only, a lot of the dual band devices
Right.
will translate power line only devices into a
Into the RF side.
and vice versa. You can then inject wireless to power
Onto the power line. Right. So it's very accessible that way, but
Exactly.
it's completely open. Any other questions? So I did have a sender. I didn't show off the sending specific, but yeah, I can turn on the light as long as I know a controller to it. I can turn on that light or turn down your thermostat or whatever it would be. So
Presumably, a lot of houses have external power jacks.
right.
So I don't even have to get into your Wi-Fi.
No, if you were to set up a power line version of this,
It's not
Right.
even Wi-Fi. That's not Wi-Fi. That's its own proprietary.
it's a proprietary thing.
Yeah.
Right. And then went back. So on the user's interface, like in the apps, no. This is all behind the scenes happening. It does not show up on the apps at all. Sorry? I think that's what it is. It's the Insteon brand hub that I got.
But you could use the ISY. There's no difference. It's a controller just like their own.
Okay. There you go. Oh, okay. So I'm not adding devices to the network though. I'm just simply using the spoofed addresses. So it's nothing new to the network.
But each of the devices will still report a change in state. So if you are controlling a device, that change in state is still seen by.
Mm-hmm. Gotcha. Yeah. So interesting stuff. Good questions. Thank you.